Sir Kannan Gopalakrishnan. He was working as a senior architect at Engineering Design Research Centre, L&T Construction, India's largest construction company. He's also worked on projects ranging from institutional buildings to international airports, apartment complexes to aircraft hangars. He's also attended 3 international conferences and 2 national conferences, and has also presented technical papers at the Jawaharlal Nehru University, Delhi, and the MSRIT, Bangalore. He's also won the national championship at Archaman at the India's largest architecture quiz. Sir Kannan Gopalakrishnan currently runs a design firm, Habitat Design Studio, and he is also a visiting faculty at the renowned architecture schools in Tamil Nadu.
Welcome to UGC lecture series. This is lecture 4 in the series of structure and architecture. We have covered unit 1 in 3 lectures, and we are going to start with unit 2 in this lecture. In unit 1, we saw the importance of structures throughout the history. We saw the evolution of architecture and structure, which went hand in hand. We saw rock-cut architecture, monolithic architecture, trabeated structures. We even saw arches, vaults, domes, buttresses, flying buttresses. In this episode, we saw tented and masted construction, different parts of a tent, how a tent works, how a tent feels, tensile structures and tensegrity structures. We saw different types of bridges. We saw the classification of bridges according to their functional typology. We saw animations of bridges according to the way it functions. We saw evolution of bridges from ancient to more modern bridges, and with that we have come to an end of the first unit in the last episode, and in this episode we will be looking at a few snapshots into the second chapter. Today we will be looking at modular construction predominantly. Let us get into the subject. By definition, modular buildings are sectional fabricated buildings that consists of multiple sections called modules. This might be a little vague in understanding, but if you look at the more detailed definition right below it, you can see that modular construction is a term used to describe the use of factory produced pre-engineered building units that are delivered to site and assembled as large volumetric components or as substantial elements of a building. Every single word in this definition is so important, and this definition has been sculpted so beautifully that even if you miss a couple of words from this definition, you would not get the entire meaning in its total complexity. Let us break that definition down into smaller pieces and try to understand what exactly modular construction is all about. It is a term used to describe factory produced units. By factory produced, what they mean is, we do not produce the units on the site where the building is constructed. These units are produced in an off-site facility, which is not on the site, in an off-site facility in a factory. Moving on, factory produced pre-engineered buildings. What is pre-engineered? During construction, when you are working on a particular thing during construction, it is called engineering, which is being done on the site. Pre-engineered means anything where the engineering part, the thinking part has been done before execution. That is pre-engineered buildings. Here the units are pre-engineered in a factory setup, and they are produced in an off-site facility called the factory. Describes the use of factory produced pre-engineered buildings that are delivered to site. If you see these words, that are delivered to site, again these are not manufactured on the site like I told you earlier. These are delivered to the site from the factory, which we talked about earlier, by means of cargo, by means of trucks, by means of other transportation means. They are delivered to the site and are assembled. They are not constructed there, because they are already constructed, they are already factory produced. They are assembled as large volumetric components. We do not assemble very small micro components, because if we start assembling micro components, the time taken in assembling small components is extremely high. If you start assembling by making large pieces and then start to build your units, it takes much lesser time to complete the whole building. So, they assemble it as large volumetric units or as substantial elements of a building. What is substantial here? In a regular construction, a brick is a substantial unit because you do not have to make every inch of the wall, you only have to do 23 centimeter at a time. That was a substantial measure of construction. But that type of construction was taking extremely long amount of time and labor. It was an intensive process. To speed up the process, to haste the process of traditional construction, we have modular construction technology, which will help us in taking lesser time in constructing a structure of a very similar quality. If you see what exactly these substantial elements are, this could be an entire wall in its entirety with the doors, windows, all the fenestration, all the openings together as one single component. They will be lifted from where it is kept and they are assembled onto the building with the help of cranes, with the help of other lifting tools. These substantial elements can range from a simple wall to an entire room. A 6-sided room itself can be assembled using modular construction. That is the speciality of it. If you look at modular construction, this is not a modern technology at all. This will be surprising to you to learn that modular construction is not a modern technology. The moment when man started to collect materials of similar sizes, a number of materials of similar sizes and start building, that is when modular construction started. When you carefully start collecting twigs or leaves or branches and then you start assembling them, then you have started modular construction there. When you start by chopping down wood of similar size and then connecting them together to form your wall, then you have started modular construction. Modular construction is made up of modules. Modules are nothing but simple sections which can be repeated multiple number of times and used in such a way that overall construction becomes faster and easier. But modernization of this modular construction came up much later in the history. These modules can range from simple walls to rooms or sometimes more complex structures like even lifts, staircases and even toilet modules. There are two types of modular construction. One is the self-supporting type and another one is the one with a structural network. In the self-supporting network, to explain self-supporting network in very simpler terms, it is just like using simple blocks, structural blocks like what kids play. You stack one block on top of the other block. By the virtue of the block's weight itself, the whole structure is stable. Just like what they have done in this assembly. They have constructed one panel, they have constructed another panel and then the further floors, further levels will be similar panel stacked right on top of this without any frame or any other framework to support it. Whereas, in the other type where there is a structural framework or a network is something like this. This is a structure which we saw in the previous episode. This is a tented structure where we use 4 pillars on 4 corners tied up by ropes and these pillars support the fabric or the material which encloses it and thereby becoming the structure itself. If you see the bottom picture, you can see that the framework have been raised in a building and the infills, the openings between the framework, the infills will be filled by lightweight materials like bricks or blocks or any other kind of material, thereby allowing you to construct faster, at the same time giving you the flexibility to have different sizes of windows and doors. If you see how this modular construction was started, the modernization of modular construction started with the advent of Industrial Revolution. The Industrial Revolution started in England, the Great Britain then. When the Industrial Revolution started, there was a lot of processes previously that were done by manual labor which got converted to machineries. The textile industry saw a very great boom and application of technology. Similarly, transportation industry and every other industry thereby benefited from the advancement of industrial revolution. But advancement always comes at a price. There was a huge population increase, or maybe we should even call it as population explosion in the Great Britain in the 1800s. If you look at the facts, the population of Britain increased from 10 million to 40 million in the 1800s. Manchester City, the city of fabrics, the textile hub of the world, Manchester City experienced a 6 times increase in population between 1771 and 1831. 60 years, 6 times population increase. And the city of Bradford, it experienced a population increase of 50% every 10 years starting from 1811 to 1851. By the end of 1851, what happened in Bradford was only 50% of the population of Bradford were actually born in Bradford. Everybody else had come from the nearby areas. So, the population of the cities increased, thereby requiring greater number of accommodation facilities, greater number of facilities for all these people to use. So, a large number of modular construction, increase in modular construction were owed to industrial revolution. After the industrial revolution, we had a period of wars, and we had a series of greater wars like World War I and World War II, and after the World War II, there was a massive devastation in the entire world. Britain lost more than 1/4 of its total economy. Soviet Union lost 40 million people in the war. A few of them were combat deaths, but a predominant number of them was because of starvation. Poland, the plight of Poland was pathetic because 80 to 90% of all Poland was completely destroyed. But after the World War II, what happened was there needs to be a tremendous fast increase in the kind of facilities that we are building for the people. So, a technology that needs to be constructed, technology that needs to be invented needs to be fast, that should use lesser number of people, that should use low cost, that should be very durable. That was the requirements of that period, and that is when modular architecture, prefabricated architecture helped us out. Let us quickly go to the main sectors of application where modular construction can be used. It can be used in a variety of applications starting from private houses to social housing, apartments, mixed use buildings. It can be used in the educational sector in student residences, key worker accommodations and sheltered housing, public sector buildings such as prisons and Ministry of Defence buildings, health sector buildings, hotels. The application is practically endless. If you want to look at the advantages, like I mentioned earlier, it uses less labor, it uses less money, and it is quicker in time. Those are the main advantages, but apart from that, what are the other advantages that we can get out of this modular construction? Economy of scale through repetitive manufacture, because we repeat the number of times we use the same thing, economy becomes less because we are doing it in mass. To understand this, it is very simple. If you are buying a product, if you are buying a single product, it will cost you more. If you are buying 10,000 units of the same product, you might go to a bulk reseller and you might purchase it from the bulk seller, or you might even purchase it from the warehouse. This will cost you very less than what you purchase from a retail store. The same concept, same theory can be applied to the economy of scale too. Another big advantage is rapid installation at site, and it can be installed up to 6 to 8 residential units per day. That is the speed of modular construction, and it has a high level of quality control because it is produced in a factory setup. Like I told you earlier, on-site construction is where people do it on-site, whereas in modular construction, the components of the building are manufactured in an off-site facility called factories, and these components are produced under factory settings, which means that each and every single component that is being manufactured undergo a certain rigorous set of rules and precautionary methods, so that the moment they come out as products, they come out as certified products. They cannot go wrong massively in quality. That is the advantage of factory produced products. It has a low self weight, which leads to foundation savings. It is suitable for project which with site constraints, whereas method of working require more off-site manufacture. In case of smaller sites where on-site construction is very, very difficult, so the components can be manufactured outside and it can be easily transported to the on-site facility and it can be constructed. Limited disruption in the vicinity, useful in building renovation processes, excellent acoustical insulation, adaptable for future extension. Robustness can be achieved by merging two corners. Stability of tall buildings can be provided easily by providing a steel core inside. So, there are a lot of things which are very good in modular construction. We will just look at other general consideration which needs to be done. And before that, we will take a sneak peek at different types of modules which are available. Like I said earlier, the types of modules can range from a simple wall component to a 3-dimensional 6-sided overall room module. So, one such module is called a 4-sided module, where it has all the 4 sides of this. You could see it in this picture how it is being hauled. Another type of module is a partially openable model, where if your building plan works this way, you can put modules in such a way that it can be partially opened on one side, and that side you could use it as a balcony, or you should use it as a opening, or you could use it as any other components of the building. There is another type of module which is called open-sided module or the corner supported module. In the corner supported module, the only supports are from all the 4 corners which you see in this thing. All the other things you can customize it to whatever you want. Look at the building on the bottom right, that is made out of modular construction, and it looks so beautiful. We already saw the advantages of modular construction. It's greener, it's faster, it's smarter. The other advantages are less disturbance, greater flexibility in reuse, less material wastage, improved air quality, reduced construction schedule, elimination of weather delays, because in construction when you are doing it on site, a monsoon season might be fatal to the speed of the construction, whereas here it is produced, the modules are being produced in the factory, which means even if it is raining outside, the factory can still run. And it's smarter because it's safer, it's better engineered, pre-engineered, it's produced in factory settings, it has all the very good components of a very smart building. And how it reduces time is what is being explained in this graph over here. See, the design, engineering and the permits and approvals times and site and development and foundations are all the same on both the kind of buildings, on a site built construction site as well as the modular construction site. The design and engineering, permits, approvals, site development foundations, they all take the same time. But where we are saving time is on a site built construction, building construction itself is a big component, and another big component is site restoration. Here the building construction need not be done on site. It can start parallelly when you are starting your site development, it can start parallelly in your factory, and it can be completed by the time you complete your site development foundations. Your building products are also complete, and you just have to install the site, and then you just have to place it according to your necessity, you place it according to the plan which you have already made, which takes very much less time than your regular building construction. And look at the amount of time that you have saved in using modular construction. There are a lot of considerations that you need to take care when you are doing a modular construction. Dimensional planning is one such thing. Stability and structural integrity of the component, service interfaces, acoustic performance, fire safety are all these things which needs to be taken care of. By dimensional planning, what we mean by dimensional planning is alignment and finishing requirements. For example, the building components needs to be aligned in one particular axis. So, even though the building, when you are constructing it, you do not look at it until a very later stage, but in modular construction you need to consider the entirety of the building during conceptual stage itself, because you need to take care of every single component, and only then the modules can be manufactured according to that. All the service conduits, all the fire safety measures, even your size of the fenestration windows, doors, size of openings, size of ducts, cutouts, everything need to be pre-engineered and predetermined, and only then we can start the construction, and only then the construction will go smooth. The grid planning, and it needs to be designed for transportation. There is a very big disadvantage in this modular construction because during transportation anything could happen. The modules that you are going to design needs to be transported from the factory on-site off-site facility to your site, which means it needs to be transport friendly. The truck size, the maximum size of the truck which can carry your thing, the truck size of the truck kind of determines the size of the building itself. So, each component cannot be bigger than the maximum allowable size that can be transported on the truck. So, that is a great big limitation to the construction, to the particular technology, which needs to be taken care of during design stage itself. Coming on to disadvantages of this thing, volumetric. Modular building sections take up a lot of space, which means you need to definitely set up an offsite facility. That is a disadvantage. Flexibility is lost because the module size can be limited. How is module size limited? For example, if you take a room, you can design the room for 3 meters by 4 meters size. You can design the same room for 4 meter by 5 meter size. You can even design the room for 7 meter by 8 meter size, 10 meter by 10 meter size. You can make the rooms as big as possible. But if your room is made up of 10 meter by 10 meter size, transporting an entire 10 meter by 10 meter thing will be very, very difficult, because one thing is we won't get a transport facility that big. Another thing is, even if we could transport it, lifting the whole thing up by means of cranes will become very difficult, and there is a greater chance of breaking and damage due to lifting and transport. So, what we do is we split up, if you are to design a 10 meter by 10 meter room, split up the whole room into different components, different sections of the wall, then we manufacture it separately, then you bring it. Sometimes if you design 2 rooms, one room is 3 meters, another room is 3.3 meters. Sometimes you may have to sacrifice the room sizes to make sure that you have one size and not 2 sizes. Sometimes there is a limitation in the number of modules that you can build. For a certain site, there could only be a certain number of modules which can be designed and built, because producing an entirely new model requires a mold which needs to be created, and that requires a lot of money and a lot of effort. So, with the limited number of modules, if you can design the connections properly and if you can start constructing it, that is the best way to do a modular construction, which means the sizes of the modules are pretty much restricted. So, great amount of creativity, increased amount of creativity is very, very difficult to achieve in modular construction. Coming on to another disadvantage, market acceptance is a great disadvantage here, because anything that can be assemblable, anything that can be put one by one is always dismantlable too. So, moment you say it is dismantlable, people think that okay, it is not a very sturdy type of construction, you can dismantle it at any time. If that is the case, people get the stigma that this type of construction is not a very robust, it is not a very strong type of construction, and people will start neglecting this type of buildings, even though they are very good. Anything that is cheaper than a regular product, anything that takes lesser time to build than the regular type of construction is considered to be a compromise on quality. That is a general view of the public, at least the layman's view of looking at it is what is, they look at it as the conventional methods are good, and the new methods in which we are trying to reduce the time and increase the quality or increase the cost savings are all compromising on quality. We need to educate the people about the importance of this kind of technology that can save us a lot of money and a lot of resources and a lot of time. We need to educate the public in such a way that they do not have this kind of inhibitions when they are going for a new kind of technology. To sum up this episode, we learnt the history of modular construction, we learnt how it started, we saw from industrial revolutions to wars and what made modular construction interesting, what was the requirement of modular construction, why it was necessary. We saw how modular technology works, and we saw the basic types of modular technology. We saw that there are 2 types of basic things. One is the self-supporting type, and another one is the one which has structural network. We also saw that the different types of buildings, the different types of places where modular technology, modular buildings can be used, applications. We saw the advantages of modular construction. We saw n number of advantages which this type of technology had. We saw the different types of modules, how it looked, how it felt, the closed module, the semi-open module, the single wall module. We saw different types of modules. We saw general design criteria, design consideration which we have to consider while designing a modular building. Then we saw the disadvantages of modular technology finally. And with this thing, you should be able to try and answer some of the questions here. Not all the questions has the answer directly put on the slides which you saw just, but do try to do some research on your own, do try to do some more reading and try and answer these questions. Try and trace the evolution of modular construction. What are the broad classification of modular construction types? Explain them with examples. Explain the advantages of modular construction. What are the types of buildings for which you would recommend modular construction and why? Brief the disadvantages of modular construction and explain why these disadvantages occur. With this, we come to a close of lecture 4 of this series. In the upcoming lectures, we will be looking at other types of buildings such as modular long span structures, suspension structures and other types of structures. So, with this we come to an end of this 4th episode of modular construction. Thank you.